Hey team, how we going? Just give me a second, I'm just loading up a few things. Can't see my notes. Hey Blank, welcome back. I just can't remember where I'm up to today. Part 6. What did we do on Sunday? I think we did some really quick normal distribution questions. We're going to do inverse normal today, so bear with me. I'm just trying to get my notes. Hey David, welcome. Probability methods. All right. How's everyone been? How you been, David? Is Hudson here today yet? Are we still waiting? Standard normal distribution. Okay, we did that. What's next? Did the Z value, calculate probability. Yep, did all of that. Reading normal tables. Did this. Between a value. All right. No, did this as well. Did that as well, that's fine. Using graphics calculator, we've done. So we're up to inverse normal today, folks. So I'm gonna need the table. I just realized this. I was right. I thought I was gonna do something else with normal distribution first, but I guess not. Now we're gonna do inverse normal distribution today. So just gonna go grab the table first. Okay, so to get started today, as I mentioned before, we were going to do inverse normal distribution. So all this time you go, oh no, what happened to my pen? Here we go, we've connected. So we're going to be doing inverse normal distribution. So what that means is we will be given the probability, and then we've got to actually work backwards. Hey, look, perfect timing. So in other words, what's going to happen is the questions are going to look, and I think these questions end up being kind of like, well, the basic ones are achieved, but like most of the time they end up being like merit questions. So we're going to be doing probability of, I don't know, Z. Let's do it something like, we'll start off with a simple one, right? So probability of it being Z, and I'm gonna put this as little x right now. Maybe not x, doesn't matter. And then I'm gonna put this as equal to 0.25. So basically what the question's asking here is, like, if I was to draw this as a diagram, and let's say because it's Z is already found, so that means our mean is going to be 0 and our standard deviation is going to be 1. And the question's actually asking us, what is this value here, so that the probability is going to be 0.25. So we've got this yellow part that is actually equal to 0.25, and the question's actually asking us, what's the x value going to be? That's what we need to do. We need to kind of work backwards. Now, as always, I'm going to show you folks how to use the tables as well as using the graphics calculator as well. So we'll show you both methods. Now, I need to remind myself to send a message to good old Grant so I can get my other calculator. Someone needs to remind me later. I'll forget it probably because I only remember it every time I start the stream. So anyway, we want to look for this x value that's where the probability is 0.25. So what you have to do is you have to go into this area here, into this table, and you've got to figure out what is where 0.25 is. So I'm going to do that, and I can kind of see here that it's going to be somewhere in 0.6 line. And if I keep going along until I get to, okay, yeah, so there you go. I can probably get up to here, 2486, and then 0.2486, and then I've got to go to the end. And if I go to the end, the best I can do is 13. So what I'm doing is 0.2486 plus 0.0013. I think this is the closest I'm going to get to 0.25. Now, if I look at the number first, so the first number I'm going to be looking at is the 2486. So 2486 is here. That is 0.67. So then I can actually say x is equal to 0.67. And then finally, the 0.0013 is from here, and that's equal to 4. So I'm going to actually write this in different colors so you guys can see where I get it from. So that's going to be 0.674. So x is equal to 0.674 to get the probability as 0.25. Now, if we were to do this in the graphics calculator, and yes, you are allowed to use the graphics calculator, by the way, in the exams. What we're going to do is we're going to go into menu, and we're going to go to, where do we go? I always, stat mode, that's right, stat mode. And we're going to go to distributions, normal. But this time, this is what we've always been using, NCD, but this time we're going to go to inverse N. So we're going to click on inverse N. Now, here's where you've got to be a little bit, I always get confused with this. Let me just draw this. Yeah, area is, give me 1 second. I just want to try something here. Because, see, this, in the newer calculators, you can actually get the drawings. I'm sure of it, that you can actually get the picture of what it actually looks like. So in the older calculators, we got to be a little bit more creative in how we actually get this. So what we're going to do is notice how it says tail is left, and then we've got right and center. So with this one, I guess I'm gonna, if I put left tail as 0.75, sorry, I'm just gonna give it a go, because I haven't actually done this in quite a while. Yeah, okay. So, and if I go right, 2.25, what am I? I should get that. Yeah, okay. So basically, with the calculator, you've got these three little three options that's happening when you get to tail, right? So you've got to think about it like this. If you're going to go with the left tail, and remember that this is x right now, and this is 0.25, but the green part is actually 0.5. So if you're going to go left tail, so left tail is this part here, that's equal to 0.75, because you've actually got 0.5 here and 0.25 there. Now the other version you could do is you could actually do the right tail. If you were to do the right tail, because the yellow part is actually worth 0.25, the right tail is going to be the pink part. And the pink part we can figure out as 0.25, because we do 0.5 minus 0.25. So if you decide to go with the right tail, then your area is equal to 0.25. That's actually from here. So just be mindful of that. And then you're pretty much good to go at this point. So when we go into the calculator, what I'm going to do is I'm going to do the left tail first. So when I go left tail, I'm going to put the area as 0.75, because when you look at the diagram that I've drawn, the left tail is the red circle there, and the right tail is the pink circle there. So the left tail is 0.75, so we're going to put that as 0.75. We're going to put the standard deviation as 1 and mean as 0, and when we press equals, we are going to get x is equal to 0.674. Now, the same way, if we were to do the right version, hey, Sarah Deep. So if we actually go the right version and then put that down to 0.25, then once again, we actually get x is equal to 0.674. So with this calculator, it's really important that you understand the right tail and the left tail. And I think once you understand that, these questions generally are pretty straightforward. So what we'll do is, yeah, we're gonna do a couple of practice questions first, see how we go. And I think if you're comfortable, then we can do some word questions. And if you're comfortable after the word questions, then we can actually go do some exam questions. So let's try these ones here. By the way, if there's any questions, please ask. I'm happy to answer before I move on. I'll give you a minute because sometimes people have like a little stream delay. So let me know if you have any questions. Second delay. That's not too bad. All right. So let's get through some questions here. Now, these questions I am going to use the calculator. So if you want to do it manually, that's absolutely fine. But we are going to use the calculator for these ones. All right. So what we'll do is I will actually draw the diagram so you can kind of go from there. All right, number one, we are going to have 0.4, and maybe we'll call this little z. I think that's what they call it, if I remember correctly. And your mean is 0, standard deviation is 1, and your area is going to be 0.4. Question 2. This is Z. And once again, I'm going to use only mean and standard deviation as 1. So we'll do 3 questions just to see how we go about it, right? Now should we do all situations? Yeah, let's actually cover all the situations, and that way we don't have to worry about it. Number 4. That's a terrible bell curve. That's not gonna work. Just realized. Oh no, maybe we can do it symmetrical. Yep, cool. Let's give those 5 a go. And I think I'm going to put down mean as 0 and standard deviation as 1 in this case as well. So again, folks, I'm assuming that you're using the calculator in this. If you're not using the calculator, yeah, it's going to be a little bit more longer, but it can still be done like I showed how to do it earlier. So I'm going to give you folks maybe about 2 to 3 minutes, see how you go. And then when you're comfortable, give me an emoji and then I'll actually start doing the answers. Did I log it? All right, people, let's go through the answers one at a time. I'm going to go through the calculator. I mean, if you want me to go through the long method with the table, just let me know in the chat. Otherwise, I'll just power through these with the calculator. All right, so looking at question number 1, I'm actually going to go with right tail here because the right tail is easier for me to find. So the right tail is going to be 0.1 because I'm going to get 0.5 minus 0.4. So I'm going to go into area and I'm going to click on 0.1. And what I've got here is the little z value is equal to 1.281. Next is I've got, sticking to the theme here, I'm going to go with right tail again. Well, I mean, you don't have to, because I'm going to go right tail here, which means I'm going to include all of this. So that's going to be 0.5 plus 0.35. So that's going to be 0.85. And my standard deviation and mean is not going to change. So I'm going to leave it as it is, which means I actually end up with a negative value. And that's okay, because z is equal to negative 1.036. And the reason, if I am getting a negative value, I know I'm correct because I know that 0 is right here. And if 0 is there, anything before that has got to be a negative number. So I know that I've actually done it correctly. Looking at question number 3, my area to the right is going to be 0.1. But let's just go left anyway. Let's go left and we're going to put it as 0.9 because the area under the curve is 1 and 1 minus the 0.1. So this entire pink area is going to be 0.9. And again, there we go. And I'm going to get x is equal to 1.21. Now, I just realized that's pretty much the same question as question number 1. And that's fine. All right, looking at question number 4, I'm going to go with left tail again, but this time I'm going to go 0.24. And I'm getting z is equal to negative 0.706. Now, just to show you, if I do make a right one, then I need to put this as 0.76, which is 1 minus 0.24. And again, I'm getting the same answer. So it doesn't matter whether you go right or left. As long as you put the right area under the curve, then you are pretty much good to go. Question number 5, what we've got is we've actually got a symmetrical graph here. Now, I know it doesn't look symmetrical because of my beautiful drawing skills there. But you've actually got negative z and you've got positive z. So it's kind of, we can kind of say that it's symmetrical. So in this case, you could just go center if you'd like. And put that as central and put that as 0.682. And it's giving me my two z values as the first z value is going to be negative 0.998 and the second z value is going to be positive 0.998. Now, if for some reason you want to actually kind of go, well, how would I do it the other way? You could have just divided 0.682 by half. And when you do that, I forgot to divide by 2. You get 0.341. So this here is 0.341, which is this part. Then we're going to get this part, which is also with 0.341. So you could go 1 minus 0.341. That gives you, no, not 1. We got to do 0.5. Sorry. We got to go 0.5 minus 0.341. That's going to give you 159. So the 159 is, I need a different color, is the orange color there. That is going to be 0.159. So if I go into my stat mode, go to distributions, normal, and inverse normal, and if I go left and then go down to my area. I'm going to put that as 0.159, and I get 0.99, negative 0.998. That wind is horrible. All right, and likewise, if I go back and put right side, I'm going to get 0.998. That's the positive version of it. Awesome. So let me know if you have any questions with this. If not, we can actually move on how to find what are we going to find out next? We can actually do it with real word problems actually. Yeah, give me a second. Let me just have a quick look at the word problems. Yeah, I'll pause there. Let me know if you have any questions. If not, we can I'll start getting some word problems ready for you guys. Hold on. All right, folks, just copying the questions over. Just bear with me. Okay, all right, let's do some word questions here. They're just popping up. Bear with me. There we go. First one. So this time what happens is that we've actually going to get, we're going to actually end up getting word problems like this, and we've got to try and figure out what the actual values are. So what I'm going to do is I'm going to let you give this a go, see how you go, and then I'll give you maybe a couple of minutes to try it out, and then I will go through the answers after that. Before that, let me just... Where's my questions at? Come on, man. There we go. That's better. So let's try those questions there. Like, just try it out. See what you get. Pretty much the same idea, guys. You just got to find the Z value and kind of work backwards in this. But I think your calculator will actually do it for you. But I am going to show you how to do it manually as well. I'll give you another 20 seconds and then I'll start going through the answers, all right? All right, so let's start going through this. So what we got is we've got height of tomato plants, blah, blah, blah. And then what do we've got? We've got distributed with a mean of 85 and standard deviation of 6. Now, what's going to happen is we kind of need to draw a diagram. I always like drawing a diagram because it makes sense for me. So I'm going to put this as mean as 85, standard deviation of 6, and it says above what height do the tallest 10% of the plants grow. So that means I am actually looking for this x value here. What is this value such that the yellow part here is going to be 10% or 0.10. So with that in mind, now with the calculator, it's really easy because all you're really doing is just punching a bunch of buttons. So you go into stat mode. In this case, your right side is going to be 0.1. So 0.1, and your standard deviation is 6, and your mean is 85. And you press enter, and voila, there is your x value. So in other words, the probability of x greater than 92.68 centimeters is equal to 0.10. Now, as I said, like in the calculator, it's really, really easy. But on the odd occasion, these guys, they like to mix things up where they will make you use the formula in a particular way. So what I am going to do, though, is I'm going to show you how to get the 92.68 manually as well. Now, the 0.1 part, I'm going to do the long method, all right? So you got to bear with me in this. So first things first, if I want to find 0.1, I need to know what the green area is if I'm actually going to look in the tables. Right now, the green area in this question is going to be 0.40. So I'm going to go back to my tables, and I'm looking for, let me just get rid of all of this. I'm looking for where 0.40 is. And I think somewhere here, there's 3997. I don't have a 3 after that, so it's going to be this. So it's going to be 1.281. And we kind of did this earlier in one of the questions, because like if you look at this question here, when it was 0.4, 1.281 was the Z value. So when we come back to our question, what's going to happen is, it's all right, Hudson. So what's going to happen is we can actually say that this little Z value equals 1.281. And so if the Z value is 1.281, we can then go into the formula and we would have Z is equal to X minus the mean over standard deviation. Now the Z is 1.281. X is what we're trying to find out, minus the mean, which is 85, divided by standard deviation, which is 6. So we got to do a little bit of algebra here. And the way we're going to get rid of that 6 is we're going to multiply it on the left-hand side. So we're going to get 6 multiplied by 1.281 equals X minus 85. 6 times 1.281, I'm going to do this the long way. So I've got 6 star 1.281. So that's going to give me 7.686. And then I've got X minus 85. Now I got to bring the 85 to the other side, which will make it positive 85. And I've got 85 plus 7.686. So then X is equal to 92.686. Now, as you can see, this is a bit long and tedious way of doing this, but like every now and then they'll throw a question where they'll make it they will make it so that you won't be able to use the graphics calculator to do this. So it's always a good idea to have this as a backup just to know how to do these things. Now I'm going to pause here. Just let me know if there's any questions that you want to ask. Oh, Hudson, it's all right, man. Like, look, you come and go as you please, mate. Like, it's no stress. Everything gets recorded anyway, so you can just come and catch up later. But yeah, let me know if you have any questions, and if we're good, I am happy to jump on to the next question. Okay, it's fairly quiet. I think we can kind of say let's move on to the next one. Oh, battery's running out for this. I'd like to, Anish. I don't know if I'm going to have time because I've got so many people asking me for numeracy co-requisite at the moment. All right, let's try question number 2 here, people. It might just be a crash course, Amish. What is this? Okay, got it. Please let me go. It's like I'm trying to set up a TikTok as well so I can actually stream on TikTok, and it just ends up with like stupid things. All right, guys, question number 2. We're going to get started with this one. Why has this decided to go? This is why you never try to set up things in the middle of doing things. All right, question 2. What we've got is normally distributed with a mean of 1,200. So we've got mean of 1,200. Standard deviation is going to be 100. And then what we've got is below what lifespan do 5% of the bulbs fail? So it's because it's asking for bulbs failing. So we're probably going to go with this side here. Below what lifespan do 5% of the bulbs fail? I guess yeah, that's fine. I think this is going to be the 5% right here. So with this, what we're going to have to do now is we kind of have to go figure out the Z value again. Or if you were to do this in the calculator, you can find the X value straight away. Because all you have to do is head into stat mode, you go to distributions, you go to normal, inverse n. Now the right side of the tail, this is left side, sorry. This is left side of the tail. We got area of 0.05. Standard deviation is going to be 100. And then the mean is 1,200. So click this, and what I've got here is 1,035.51 hours. So that's the actual answer for this question. However, what I want to know is, to show you how to do the long method. The long method, what we have to do is we've got to figure out this part here, the green part, to use the tables. Because it's symmetrical, we know that this right here is 0.05. If this is 0.05, this is going to be 0.45. So then we've got to go into the tables and figure out where 0.45 is. 4495, and then I've got 5 there. So basically looking at 1.645. So with that in mind, then I can say that Z is equal to 1.645. Now you got to be careful with this, because remember that this Z is actually on the other side. So you just have to use the, you can't actually use the positive one. You actually have to say that Z is equal to negative 1.645, because the positive one is here and the negative one is actually on the other side, on the left hand side. So we've got the formula Z equals X minus mu over standard deviation. So you've got negative 1.645 equals X minus the mean, which is 1,200, and that's divided by 100. So next, I'm just going to cross multiply this. So I'm going to get 100 multiplied by negative 1.645 equals X minus 1200, and then X minus 1200 equals negative 164.5, and then X is equal to, the 1200 moves to the other side, it becomes positive. So I'm going to get 1200 minus 164.5, which gives me X is equal to, let's just go into the calculator very quickly. We got 1200, take away 164.5, and that's going to give us 1035.5. So yeah, that's pretty much the long method. As I said, you can use the calculator, but it's always good to do the diagram and then, yeah, just get the answer right real quickly in the calculator, right? Okay, let's go to question 3. Actually, no, let me just pause here. Let me know if there's any questions that we have so far. Import from another tool. Go live now. All right, so what I'll do is I'm going to put up one more question here, question 3. I'm just trying to think if there's any other versions of this question. Yeah, so in the next session, what we'll be doing is we'll be doing inverse probabilities, inverse normal again, but what we'll be looking at is finding the mean and standard deviation, because that's how the questions have changed. They're starting to ask questions where it's not as straightforward as using the calculator itself. For beginners, set up now. General. All right, guys, we're going to do this last question and then we're going to pretty much call it for the night. So, last question here. We've got, I'm going to draw this out. The mean is 540, standard deviation is 45. What have we got? Reaction time, test track, normally distributed to that. What's the minimum reaction time needed to be in the fastest 15% of the drivers? So fastest 15% of the drivers. Now this is I think this is a trick question. Because if it's the fastest 15%, it's actually going to be the left tail, right? Because you want to, if you want to be fast, the reaction time has to be, it has to be, what do you call it? Small. So that means this is your top 15% right here, because it's reaction time and you want it to be as quick as possible. So that's going to be 0.15. So what I want to do next is I want to be looking at the green area in, I'm going to do this a long method first, which is going to be 0.35. So this is going to be Z1 and Z2. So I'm going to go find what Z2 is, 0.35 first. All right, let's go find 0.35. I've got 3485 and 14. So I'm looking at 1.036. So, because that gives me closest, it gets me to 0.3499. That's close to 0.35. So 1.036 is the value I'm looking at. Okay, so Z2 is 1.036. Z1 is negative 1.036. So Z equals X minus the mean over standard deviation. Negative 1.036 equals X minus the mean, which is 540, divided by standard deviation, which is 45. So cross multiply. I've got 45 multiplied by negative 1.036 equals X take away 540. And then I could actually do this, which is 45 times negative 1.036. So that's going to give me negative 46.62. And then bringing the 540 across to the other side, it becomes positive. So 540 take away 46.62. That gives me a value of 493.38. Now let's see if we're actually correct. I'm going to go into the calculator. Let's try it out. So go into distributions, normal, inverse. My left tail is 0.15. Right, no. 0.15. Standard deviation is 45. And then mean is 540. 493.36. Close enough. Anyway, guys, cool. That's pretty much it. And I think what we'll do tomorrow is we'll probably cover, not tomorrow, on Thursday, we will cover the mean and how to find the mean and standard deviation for inverse normal. And then that should pretty much set you up for inverse normal questions. And I think after that, we've only got a couple of small things, absolute risk, not absolute, relative risk, and then we should be good to go. But yeah, thank you so much for joining today. I'm sorry, I just got distracted a little bit. I'm trying to set this thing up on TikTok as well, just to see if it's worth streaming there or not. I don't know. Would love your feedback on it. Hey, Sniper, welcome. But yeah, guys, thank you so much for joining today. That's us done today. Tomorrow there is a t-shirt giveaway, by the way, so keep that in mind. You got to be in. There's going to be a Google form that'll be sent. You just fill up the form and you got to show up to win. So it's the most important one. Show up. Because like most people enter the enter the giveaways and then don't show up, and then they win t-shirts and then they don't get anything, and that's a bit sad. Actually, give me a second. I will set it up right now as we speak. Where is it? Drive. I'm actually going to Selwyn College tomorrow. It's been should be good to visit them again. It's been a while. Let's see. Giveaways. Here we go. 2025 giveaways. Oh wow, I've only done like not many. Open with make a copy. Hang on, folks. I'm just setting it up right now. I've got to rename the whole thing. What are we doing? July 29th. 29 July 25 t-shirt giveaway, blah blah blah. Yep. Done. Publish. Responders. Anyone with a link? Yep. Copy responder link. All right, here we go. That's the form you need to fill up, people, and then show up tomorrow. Make sure you show up, because most people just like, yeah, we're gonna come, and then they never show up, and they don't get it. Fill the form. All right, that's all done. I've set up everything for tomorrow. So yeah, feel free to jump in tomorrow. Now, I'll hang out for a couple of minutes, guys. If you have any questions, feel free to ask. Otherwise, as you can see, my laundry is waiting to be hanged. That's just a reminder for me to put the laundry out. Hudson, you're already in, man. Nice. I'll see you tomorrow morning. Tomorrow, Hudson. Blank. You don't need to put your full name, as long as it I know that when I can send a message, like if I'm sending a post, if you win something and I'm sending a post, it's a bit weird when I have to send it to usernames, because people are like, oh, who is this person called blank? So even if it's just your first name, it makes it easy. Just in case it goes to your neighbor's house or anything like that, they can go, oh yeah, this is a person I know. I can actually drop it off. 8 o'clock tomorrow. And of course, we're going to go with our choices: gold, white, or shiny holographic Infinity +1 logo. Did I put 8 a.m. by mistake? Oh, that'll be awful. No, it's 8 p.m. dude. 8 p.m., mate. Definitely 8 p.m. I got to go to school. Actually, no, tomorrow I'm not at school. I'm at Selwyn College, so... All right, let's see. All right, guys, if that's basically it, I will see you tomorrow. Looking forward to it. 3 t-shirts up for grabs, eh? Yeah, have a good one. And as always, thank you for watching.